Hello, welcome to this tutorial on how to implement an adaptive staircase procedure on PsychoPy. So we employ staircase procedures to titrate the minimum intensity value of a stimulus for detection. For example, in an orientation discrimination task, what could be that minimum orientation difference which will result in participant responding correctly whether a particular grating was tilted to the left or tilted to the right. So what is that critical or that threshold orientation difference that we need? So this can be done by using an adaptive staircase procedure, and this in this tutorial we'll see how to estimate that for an orientation discrimination task. Although this could be implemented for contrast detection or any stimulus intensity values that you might want to titrate for. The procedure is flexible in that sense. Today we'll be looking at a very simple orientation discrimination task. The task of the participant is to correctly identify what the tilt of a particular gabor patch is. It could either be tilted to the right or to the left. In other words, it could be tilted clockwise or counterclockwise. So that is going to be the task, and we need to identify what is that minimum orientation difference that is required for detecting or accurately discriminating the orientation in this case. All right, so let's start with a fixation cross. So this is going to be a fixation that is going to come on the screen at the beginning of the trial and going to stay there for 500 milliseconds. It's going to be a cross, and the size of the cross is 0.1 by 1. We'll stick to the experiment settings for the spatial units. So we have the fixation here. After the fixation, we have a grating. So a grating is defined by many parameters. For us, the critical parameter is the orientation. At what orientation is it? Is it presented? So let's go ahead and add a grating. Now this is our grating, and it should start after the fixation, and it should stay there for, let's say, 300 milliseconds. Now in the layout tab, you can specify the orientation. Remember, this is the one that we are going to change. This is the variable parameter in this. So we have to change this to set every repeat. Size 0.5 is slightly larger, so let me change it to 0.3. Okay, so it doesn't really matter. And also depends on the kind of task that you're going to perform. Contrast 1 is the max value, so let's go for 0.5 as the contrast value. And in texture, you can specify the mask that you want. Do you want a circular mask or more a Gaussian mask? In the Gaussian mask, the boundary will be slightly blurred, so let's go for the Gaussian mask here. Spatial frequency defines how many stripes that you will see on a grating. So let's give 8. So that's going to be our grating. So remember, we need to come back and give a variable here which we are going to define. We'll define that later. So that's why we have our grating on the screen. We also need a keyboard response. Keyboard response is basically what is the orientation. The task is basically asking participants what is the orientation of this grating. So let's say they need to press left arrow key and right arrow key depending on which way it is tilted. So allowed key responses should be left and right. Duration, again, it starts, the response window starts the moment grating comes on the screen and stays until the key is pressed. Now go to the data tab, and here we can specify the correct answer, because this is very important in an adaptive staircase procedure, because the staircase procedure uses the correct answer to determine the next the stimulus intensity in the next level. So this again should be a variable. We will come back and define that later. Now, in this case, in every trial, we need a variable orientation. So it should be either left tilted or right tilted, and the tilt should be a varying value. So we need to specify that, right? So for that, we have to add a few lines of code here, and so we'll just go here and click on the custom tab and insert the code here. So you need to insert the code at the beginning of the routine. So what's going to be our what do we need? So we need with 50-50 probability, we need the grating to be oriented to the left or to the right. Okay. So let's see, if random of is greater than 0.5, so this just means that it just picks a random value and random value between 0 and 1, and it will check if that random value is between 0 is greater than 0.5 or less than 0.5. That's one of the ways we could generate, we could create a particular sorry, it's gone. Yeah, we could create a 50-50 event on PsychoPy. Just one way of doing it. Okay, so I'm just pasting that code here. So if random greater than 0.5, the direction that we need, okay, this is going to be the tilt variable, which we will define later, is going to be minus level, because if you want something to be oriented to the left, you have to have a minus sign. In that case, the correct response would be left. Else, if the direction is positive level, so now level is something that we will talk about later. Level is going to be a number. It could be 1, it could be 10, it could be 20. So that's going to be the value of the tilt. So a 10 degree tilt in the positive direction would be to the right. A 10 degree tilt to the negative direction will be to the left. So that is what this means. So only difference is the polarity of the value level. If it is to the negative, you have left. If it is to the positive, you have right as the correct response. So this is what we need to add at the beginning of every routine. Okay. Now here the critical thing is this: direction and correct response. These were the two variables which we left when we defined the grating and the key response. So now we will go back and add them into the PsychoPy builder, into this component. Okay. Okay. So we have two here. So let me remove one. Okay. All right. So we have this code here. Let's call it 50-50. Yeah, this is how you create a condition with 50-50 probability. So condition where the direction is to the left and the correct response is left arrow key, and here the direction is to the right and the correct response is right arrow key. So we have that, and now we need to go and change it here. Right here the correct response is the variable that we've defined. So it is correct response. Now we have that variable here, and in the grating we need to go and change the orientation to direction. In both cases we need to set every repeat, change it from constant, set every repeat. And there's one more little thing, this line of code should be, we should move it to the top. That's because this code is read initially. If, for instance, if you keep that code down here, PsychoPy will throw an error saying, level is undefined. So, this is one way of getting around that. So you need to, bring that code component up here. Okay, that should be good. Now we need to add our adaptive staircase loop. Okay, so this is basically a loop which we add around our routine, and in the loop type change to staircase, and In a staircase procedure, there are a bunch of parameters that you need to define. First, how many repetitions you need, which is basically how many trials you need. If one repetition is a trial, in this case, every repetition is a trial for us. If you keep it at 50, it will run 50 times. Now, there is an alternate way of doing this. Instead of n reps, you can also specify the reversals. Now, what is a reversal? In an adaptive staircase procedure, the intensity value, in our case, the orientation difference, let's say a 10-degree difference from the vertical could be one intensity value, 5-degree difference from the vertical could be another intensity value. Now 10 is more intense than 5, so 10 has higher intensity than 5-degree tilt. Okay, so that is now depending on the actual response, whether the participant got it correct, did they actually press right arrow key when the tilt was to the right? If the answer is correct, then the intensity value will be reduced in an adaptive staircase procedure, and if the answer is wrong, the intensity value goes up. So this is the basic idea of an adaptive staircase procedure, and here we specify the steps at which it goes up or down. So here by default it is a 3 up, it's a 1 up, 3 down procedure. Depending on what values you use for up and down, the overall accuracy after, let's say, 100 trials would be different. So you can refer to the textbook. Textbooks give you that estimated value. If, let's say, if you want 70% accuracy overall, then you might want to go for a 2 up, 1 down procedure. So it varies. There is a table that specifies that. Okay. Now reversal. What does it mean? To set instead of n reps going for n reversal. Just means that if you go for n reversal instead of a fixed number of trials, this adaptive staircase procedure will terminate after a fixed number of reversals from up to down. For example, let's say the intensity values, so you're giving correct answers and the intensity values are going down, and at some point you made a mistake, the intensity value goes up. So that's a reversal. Now you can say, okay, I will be okay with, let's say, 5 reversals. As long as the participant completes 5 reversal, we can terminate the adaptive procedure. This is one way of terminating it. The other ways, of course, we can specify a max number. The downside of n reversal as your termination criteria is that you don't know how many trials it is going to take to complete the staircase procedure, whereas if you specify the n reps, you know when it is going to end. So that is what it means. So let's stick to n reps for this. Now start value. Start value is going to be the intensity value that you want at the beginning of the task. Okay, so for us it's an orientation discrimination task, and this should typically be an easily discriminable value. For instance, this should be a value where the participant should be accurate 100% of the time. Okay, so that is going to be our start value. So that we should sort of start easy. So let's say go for 10 as our start value, so that in the first trial it's going to be a 10-degree difference. It could be to the left or to the right, that we are not specifying here. What could be the max value? What is your tolerance limit? Let's go for 20 degrees is fine. Minimum we are okay with 1, we don't want anything below that. Now step sizes, you can specify when there is a mistake, what is the size of the sort of up step. Okay, when there's a mistake, the intensity goes up, right? So how many units should it go up? So that is what that is what means by that is what step sizes mean. So we can specify it. So we can specify multiple step sizes. So basically it will start with the larger step size and then go on to the smaller step sizes as the experiment progresses. So let's give 4 step sizes. You could give equal step size as well, that also works. Now step type, do you want the up and down happening in a linear scale or a log scale? Linear scale is more straightforward, but log scale is more efficient. You can pick the one that is best for you. So this is how you specify your adaptive staircase. So this is going to be our staircase here. All right. Now we've got our code here, which is going to be decide whether the direction or the tilt is to the left or to the right, and specify, identify the accurate response or correct response, and store that into this variable. And we have the fixation, then the grating, and within the grating you specify the direction as the variable for the orientation and set it to every repeat, and for the key response specify the correct response. So this should be good. Now if you need, for instance, there are some data points that are not really available by default on PsychoPy. So let's say you want all these, what is the correct response, what is the intensity value, then you could basically add these lines of code, which will basically add one column in your data file, each specifying these variables: correct response, direction, and whether or not the response was accurate or not. If it is accurate, it's going to be 1. If it is not accurate or incorrect, it's going to be 0. Okay, so this is the adaptive staircase procedure. Now let's let's run this. Before that, just uncheck the boxes so that we can just do the experiment faster. All right, so let's go ahead and run this. So the idea here is that when you make mistakes, the orientation differences would be larger. When you make correct responses, it will kind of sort of reduce and becomes much tougher to discriminate. So that's the idea. Okay, so we should have the fixation cross coming on the screen. Now you can see it was tilted to the right, so I'm pressing right arrow key. Again right, right, left, right. And you can see now I'm making correct responses, and it's becoming really, really tough to sort of discriminate. The orientation values or the intensity values are really, really getting down. So now what I'm going to do is I'm going to make some mistakes. Okay, so I'm going to make incorrect responses now, and let's see, if there is a change. Now I'm making mistakes here, and you can see that the orientation differences are becoming larger. Basically, it is adapting to my my performance. That is what is happening. So now you can see that the discrimination, the orientation values are really different, and it's very easy to discriminate. Now I'm going to start giving right responses, and the values should, intensity values should now get down. And okay, before that we've reached the 50 end reps, so the experiment exited. So this is how you perform an adaptive staircase procedure. And now you could ask, how do you determine the threshold value, or given this kind of what is the threshold orientation value? Because if you go to the data of this procedure, so this is the data that just came out after my performance. You can see here, this is the data column that shows correct responses. You can see I'm correct initially. Then this is where I started making intentional mistakes, and this is where I started making sort of correct responses after that. Okay, so this is the change in intensity values. It started with 10, and since I'm giving correct responses, the tilt values dropped. Then when I started making incorrect responses, the tilt values sort of increased. Yeah, so this is how the data looks. But you could ask, what is that orientation value? Assuming that I performed this experiment sort of honestly without sort of playing around with PsychoPy, you would see that the tilt response would sort of reduce through as the experiment progresses. the tilt or intensity value should reduce as the experiment progresses. What is the threshold value? Now, there are many methods to sort of identify what the threshold value is. One of the most sort of accepted method or the ideal method is to pick up all those intensity values during the reversals. Whenever there is a reversal, let's try to identify a reversal here. So you can see it's going from 3 to 2, then it sort of jumped from 2 to 2.5. This is one reversal. So if you have, let's say, 5 reversals and take average value of all those reversals, that could be sort of considered as a threshold value. There are many ways. This is one way of identifying the threshold value. Yeah, so that is adaptive staircase procedure using PsychoPy. I hope that was clear, and thank you very much.